So let me load up my Prota, and then I've also pulled up the Euro code. I don't know if we've got anything for steel in here. I remember I used to have some BS codes also. Oh, these are concrete. Like 41 something. Okay. And I'll also pull up the sample drawing so that. Okay, so yesterday we, I think we modeled the entire structure, isn't it? We did everything, and in today's video we'll be doing a lot of analysis and correcting. Which one is it? Yeah. Okay. Let's load them up and also see if I can pull up my image. Okay, so after having followed through, if you haven't been attending the sessions and you've been watching the videos on YouTube, or if you've been doing both, you've been following and you've been modeling, your model should be looking something like this, right? Remember we deleted some supports and
The screen is currently frozen.
you said the screen is what?
I can't see your drawing. It's still on the load. Okay, it's open now.
Oh, okay. It means you're lagging behind.
Yes, I think it's the network.
Yeah.
But yeah, I've been modeling as well, so my drawing is like that.
Oh, okay. That's nice. That's someone interesting to okay. So let's just run through, make sure that all of our drawings are populated. Usually do not consider this 0 0 because that's like is it the top or the bottom of the foundation? It's actually the top. When I double click, it will show me. Yeah. So if I change to my plan view, right click, plan view, I can see that I've got structural members on this on the ground floor, including the slab on grade, right? The foundation slab. How much did we model this on it? The thickness was, yeah, thickness is
The
120.
thickness of 150.
No,
150.
the foundation
Oh,
slab was 120. Then the first floor, the suspended slab was 150.
yeah, 150.
Yeah.
Oh, yes, yes.
And then we go to the first floor, we can see that it's actually showing two-way span, like the tributary. This is the image for two-way slab. And then there's that formula that says it should be your is it your L over something should be less than, is that 2 or 1? Should be 2.
The longest
Yeah,
side over the
two.
shortest side. Yeah.
Yeah. The longest side over the shortest side, yeah. I should have pulled out some of those books today. But anyway, I'm happy that everyone knows. And then these openings, the slab openings, we model them like that. So this is the first. The canopy, it shows that we've got some trusses there. And also, just a quick reminder: when you pay attention to these structural elements, you'll notice that they are numbered according to their floor. So here, uh, I went to the ground floor, right? And when you pay attention here, the C is meaning the column. It says 1C1. One, the prefix 1, the first number 1, means it's on the first floor. And this is C1. And then let's see if we've got a C2. I don't know this is a C2 column. And it shows one C2, one C3, and so on and so forth. Even the slabs, you see, one is one slab one, one slab two, one. And then if we go to the first floor, which is on the second story, right? I expect all of my elements to be 2S. If slabs will be 2S, columns will be 1C, 2C. This structure beam should be 2B. So let's zoom in, right? That's 2B, meaning it's on the second floor. Usually when you're reading those analysis reports, it gives you an understanding. So this one is the universal column, and it's being labeled as a 2C. And then if I go to my canopy, the trusses are represented as T. So 3T and the number according to the way that you were placing them. If you started with on the left or the right, it will do that. And also these purlins, you say 3P, and so on and so forth. Let's see, on the wall plates. Oh, the wall plate does have some information. That's exactly where the trusses are. So this is story 4, 4C, 4P, and so on and so forth. Is there anything on the roof? On the roof? Oh, okay, good. So let's go to building set out edit story. If you remember, we said stories or levels with information and members and information on them, they'll be ticked. So here we can see the information page there. It says number 5. This one hasn't been populated. So let's try to perform an analysis so that we can see for certain that flows Prota won't be able to analyze your perform an analysis if one of the stories are not populated. So in order to carry out an analysis, you go to this analysis tab here. You click on it. If you're familiar with the FEM, that's finite element, with meshing, what, also here, you can do these. But let me not lie to you, FEM is quite complicated. It's a complicated concept because it uses infinitesimal, very small part members to form bigger ones, and it's very difficult. Even our structural engineering teacher couldn't teach it properly. So fortunately, Prota has got this thing. It's called building analysis. It's far much simpler, and it will analyze the entire structure. FEM analyzes members. Yeah. So you go to building analysis there, and the building analysis tab comes up, and then here it tells you codes. 8110 is concrete, 5950 is steel, 6399 I'm not sure. Someone will have to tell me what that is. But these two I know for certain. So here, the first these tabs have been arranged sequentially so that you can move from one tab to the other. One tab, okay, so obedience will help you confirm. You can say BS8110, what 64, and then 5950, and also 6399. So here we've got the pre-analysis, everything that you need to do before running your analysis. You've got your model options, and finally, when these two, if you've gone through these two tabs, you can perform an analysis. After performing your analysis, you can do a post-analysis where you can have your results, and you can export your model to either DWG, I don't know if you've got FPX, or even to SAP there. If you've used and there's ETABS. If you've used SAP 2000 before, it will really help you. H110 is pre-stretched concrete. H110 should just be steel, concrete. General, yeah. Recommendation structure use of concrete, even on the right there. Yeah. How about 5950? 5950 should be structural steel. So model export here, you can export your model. I think this is like a 3D thing. I've never done it before. I'm yet to do it. The reports here you can get more information. But so let's begin. We'll go with the pre-analysis. Project parameters and loading. You go sequentially. Parameters. You click on it. here it gives you the codes. Concrete design. Oh, actually here, that's the loading code. See if you can download the PDF. Yeah. So here we've got concrete design. It tells you BS H1 10 structural concrete. If you like to change, you can change. Even though you started by modeling in BS Code, the templates will maintain, right? And then here it tells you you can reference this code. This is the loading code and the earthquake code. I do not think there are any buildings currently in Zambia that are being factored in with maybe thermal or earthquake. Like our hemisphere, this side, the southern, it doesn't have a lot of any tremors or anything like that. So here, this is good. We are not changing anything. We go to foundations. Who asked a very important question last time? How are you going to be able to know your the bearing capacity and also the source upgrade? So before you can actually start as a structure engineer, before you can start what we were doing, modeling, what, if you've got a client and they come to you and they tell you, of course, if you're a practicing engineer, right? Let's not act as if SEZ won't come for you. So if you're a practicing engineer in a consultancy firm, you have a client, they come to you, they tell you, I would like a design for a double story or a three-story or multi-story building or bridge or whatever. The first thing that you have to do, depending on your consultancy services, you can either charge them for soil investigations, then you can go to a third party laboratory like controller, bar, DA, ranking, whatever, and then they'll perform these soil investigations, and the soil investigation report will give you the type of soil, the bearing capacity, the PI, the plastic limit, PL, the plastic limit, liquid limit, and all of that information. So here, since we're working under assumption, I do not want to put a bigger bearing capacity means the soil is good, right? So since I really want to be safe and I'm working out of assumption, like we haven't done a report. So what I'll do is I'll reduce it so that I can be safe. I'll say 150, and you'll see when I go here on the source upgrade coefficient, if I select it, it gives you this, even at the table there, it recommends references, foundation analysis, and design. Table 9.1. If you can be able to find this PDF, you can always review it. Pretty sure it will give you a lot of useful information. So, oh, someone is requesting to join. Okay. Yes. So, like we were like as we were discussing, we are currently trying to key in the bearing capacity. So here it tells you loose sand, you've got the upper limit and lower limit. This should be here, this should be here. So it gives you a range. And this is in kilonewtons. This is pressure, isn't it? Kilonewton per square meter. You've got medium dense, dense sand, and so on and so forth. Here, actually, from here, it actually gives you in pascals. Newton per millimeter is a pascal, right? So a kilonewton per millimeter squared will give you a kilo pascal, right? So these are kilos, and then the other one will be meg. So right now it shows you for clay you need it to be greater than 8 but less than greater than 2 but less than 800, and then clay soil will be anything less than 200. And then if you've been on site on any site, you can be, and if you've got a certain level of experience, you'll be able to see what kind of soil it is. But then, of course, you definitely will need to carry out a soil investigation report. So here, I'll assume my bearing capacity is 150. Lateral loading, it basically tells me the nominal in the Q, in the G, and the Q. G is gravity, Q is actually this would be the dead, this would be the live. If you'd like, you can use both with a factor of n. where they tell you live load participation factor N is 0.3. So here lateral load factor, they've assumed it's that. And then the number of modes to be calculated, they're saying is 6. I'll maintain it as is. You can switch to this if you like. It doesn't really, okay, we'll keep that. And then we go to lateral drifting. Things like bracing for a lot of multi-story buildings in 203. Here, I would like all of them to be braced in the X direction and also in the Y direction. So I'll keep them, I'll maintain them as being braced. The title, you can give it a, we can say a sample for a 30-day, 31-day challenge. The day challenge. This is when you decide to export with a title block. This is what's going to appear. So they'll say like that, and then the person that will be checking it will say OBM, OBMAC. The project code 31 day or hyphen challenge. We'll give it the date of analysis. Today is the 6th, 03, 25, right? And then we'll okay it. We've done these parameters. Now we go to loading combinations. Here, Prota already has some load cases. When you click on it, the generator here, loading generator, when you click on it, it shows you vertical load combinations and horizontal. Here we only want nominal. Since it's not a building going up to about 20 meters, the wind load usually comes into play if it's 20 meters or above. So we will not factor that. We will not factor in the soil. We will not factor. Here you can factor in the soil pressure if you like. Okay, let's factor it in. The temperature loading, no, we're not designing our building to withstand any temperature, no. Also, we're not designing it to withstand any wind loading, so we'll leave that. Also, we're not designing for any seismic loading. But here it shows you vertical combinations where 1.4D and 1.6L maximum. And then also here create factor load combinations. If you like, you can say steel on concrete. Let's say steel and concrete. Okay. And then stage construction cases, I'll leave that. When I okay it, it will give me this information. LL live load. RC, I think that should mean concrete. Steel, your G, your GPIQ, QPU, and so on and so forth. Number of vertical load cases, 6, number of lateral, and so on and so forth. So this is what you need. If you'd like to, this is the P delta analysis for multi-story also. I think it's like bending or swaying or something. You can tick that if it's a multi-story. This is a simple two-story, you won't be doing that. If you're in a different country and you'd like to add other things, you can add. When you press on the add button there, it will give you some information showing I've done that. But I'll delete it since this and this are the same. I'll delete that so that I can remain with that one. Now, okay. Wind load, we just talked about that. We are not going to do that. And then here, material, extremely important. Here it gives you a default of 20, C20. I do not want to do that. I would much rather have a minimum of a C30, but then I can tell the contractor how you can design for C30. Anyway, you tell the contractor you want C30, it's still okay. And then the reinforcement grade, I would like to use S355. So here you press on edit materials, and then I usually like to start with the foundation. You can start from the top, I much rather start from the foundation. And then here for foundations, I would like to be using, when you look, it's got about 32, it doesn't have 30, so I can add. And then here I can give it a name, material name, I'll say C30, capital C30. I know for C30 at 28 days I'm designing for 30 what megapascals, Newton millimeter squared here. So I'll change. Before it was 25, so we'll say 30. And then 7 days can be either 65% or 70% of the total. This is a tensile. I know modulus of elasticity for concrete is 25, so this is good. everything else, unit weight is 24. All of this is good. Okay. And then the soil we're designing for is sand. If you'd like, you'd say rock, silt, clay. You can make those changes here by a drop down. And then let's see if it will change automatically. No, it doesn't change anything. So you'd have to key in all that information yourself. So I'll maintain my sands. The color you can change if you like. I'll okay it. And then links. Here for the grade, I'll say 460. This is the tensile strength of the steel. This is the steel. Riber diameter. This is steel. I'll change it to 460. Others would say 500. I think a minimum of 460 is good. And it tells me the tensile strength, steel bar parameters there. And then the display character. Usually in Zambia you say Y, right? So you want it to say Y, and maybe a capital Y. It only has a small Y. Oh, okay. We say Y10, Y2, Y2, other people say T. So for me, I would like my information to be displayed as Y. And then the hooks, pre-stress, whatever, and so on and so forth, I'll say okay. And then also here, I would like apply to all members of this material class so that I do not have to go on checking. When you pay attention here, it says 14, right? But when I click on that checkbox, it, it didn't. Anyway, you repeat the same thing. 460, you select, it's maintain the Y, you okay, and then the bar diameters. For my foundation, I would deselect everything. You see, I'll select all and then deselect. I would only like to use a minimum of maybe 12, right? And 16. 12, 16 foundations are good. 10, it can work, but I would much rather use 12 to be on the safe side. The biggest bar size would be 16 for me, it's okay. I'll say okay. And also apply it to other members. And then for the links or the stirrups, I would like 8s and 10s. 16 is too much. Oh, because we clicked on that. Anyway, we'll use 8 and 10. Unfortunately, we do not have 9s on the market in Zambia. I don't think we have that. No one is manufacturing 9s. Maybe in other countries. So let me go back there. I've got 10, 16, good. And here I've got 8 and 10s. Cool. Okay. And then now I have to go to default materials. Do I have any concrete columns in here? I do. I'll select my C30. I'll say yes, apply so that everything can be C30. I do not have any concrete walls, but you see how everything changed though. And you can change if you like. Okay, let's change. Although I do not have any concrete walls. Slabs 460. Okay, cool. For my columns, I would like a minimum of maybe, okay, 116, guys. It's 400 by 400. If I'm going to have any support, okay, let me say 16 and 12. If by cranking I need a support, oh, I'll show you how you can also calculate the area of C automatically. So here I'll say 12 and 16 are okay, right? For my columns, for my walls, if I had walls, shear walls, or elevator walls or core walls, I would like to use 12s and 10s and 12s. That's accepted for walls. And then you've got those horizontals and verticals. You say 10 and 12. All this falls under walls. Horizontal web bar, select, deselect, 10, 12, 10, 12. Okay. And then my concrete, my beams. Okay, someone is requesting to join. Okay. So for my beams here, I would like maybe, okay, maybe in the middle, if you like some middle, some strengtheners, maybe 10s would be nice, 12s, at most 16. And also, you have to bear in mind, think of your client, you know, think of if they're going to be buying 12s and 16s and 10s, don't throw in a 20 or a 32. It makes it extremely difficult for them to go and look for a 20 that's only going to be put in four beams, you get, because usually when you're buying in tonnages or kgs, so make try to maintain a certain level of consistency. So okay, 10, maybe if it's in the middle, and then top bottom 12, 16 is good, although 12 maybe. Anyway, you're okay. Your slabs, my slabs are only ones, 10s, and 12s. I 8s, no. 7, no. If I don't select, deselect, just 10 and 12 for top or bottom. Okay. And then for my ribs, if you had those rib slabs or waffle slabs, you can do the same. 10, 12. Aha, now here, most important, links. What kind of links do you want? If you've got 10s, do you want a 10? Why 10 link? No. So personally, I would much rather have 8s, right? 8s or 10s, but I'll leave them at 8s. 8s are okay, and are okay. And then I've cleared that part for concrete. Now for my steel, I want 355. No compromise. 275, it's got a lot of carbon. 355 is far much better for me. Yeah. Okay. So also there, if you want to reference where that is coming from, it's, that code, you're okay. So now we've done this and you see it, the information has changed. For model options, if you would like to use default, here also share slabs, what, and slab models. These are extremely important if you're mentioning FEM, finite element methods. Stiffnesses, columns, walls, you can check that. Some of this information I've never really I've never really used it before, but usually what I usually just change here could be the rigid zones. If you'd like to give it a reduction, but just maintain a none so that the system can be able to calculate in the same way that you modeled it. If you give it a certain level of reduction, then it means you're using probably a special type of cement, a grade of cement. And then your beam sections are rectangular. So structure here, user defined support is better for isolated. This one is probably like when you're integrating and you're using maybe like a raft foundation, you see, where everything will be according to one. Here it's just that the columns. This one is one thing. So I'll maintain user defined supports. And then we've gone through this. And then finally I'll go to analysis, right? Before you run any analysis, you need to perform a building check. And then this comes into what Mundia was talking about, having a steel column inside the concrete. If we've got any errors, the software will tell us. So it tells you what it's going. You want to perform a building check for all stories, and then it tells you exactly what you're going to be checking for. If you've got any overlapping slabs, overlapping column checks, like those overlapping ones that we had, so on and so forth, you click on OK. It will start. Fortunately for this model, for us, it doesn't have any errors. I've done certain analysis before. Even just yesterday, we had a situation of where Obi and I were working on something and we had errors, and then we needed to go and troubleshoot. It's a lot of work. But fortunately for us, for this video, we do not have any errors. So I'll say, okay, oh, already checked. I close. So we also have this Eugene value, and then there you want a static analysis, static what? It's called static plastic, is it? Okay, so the building analysis and design that you want is that if you wish to change anything, you can can do that. But this Eugene Valley thing for lateral loading, I've never really used it before. It would be interesting to hear if any one of you has used it before. But my design is for columns. I have those stab concrete columns and steel columns. I've got steel beams and I've got steel member design check. If you'd like for Prota to reselect bars for you, what this means is that if the bars, the reinforced the rebar that you've chosen is insufficient according to the AS, the area of steel, when you tick these things, you are giving Prota the permission to reselect those bars accordingly for you. For me, I do not like that. I like to, because it might just give me a Y14, but then I do not have a Y14 on the market. So usually I do not like to tick that box. It might give me a Y7 or a Y, but we do not have those bars on the market. So I tend not to check these, and then we'll perform. We'll start. You see, that's exactly what we were waiting. The error message says analysis can be carried out when all stories are populated. Models with empty stories cannot be analyzed. So we knew that was going to happen, but we decided to proceed anyway. So that was just so that we can see. So okay, we'll close, and then since there is nothing on the roof, we can just remove it, guys. Remove story completely. Prota will prompt you, will be removed and so on and so forth. Just say yes, it's okay, there's nothing. And then when you go to your building setup, edit story, you'll see that you remain with four, and all of them have got check boxes. Now you have to go back to your analysis. You click on the building check, and then let's see if it maintains those presets that we were doing. If not, we'll do them quickly. Okay, let's see. Yeah, it maintained the material C30, the steel's 460, right? So we'll go to everything is user defined rectangular. Okay, analysis. If you like, you can do perform the building check again just to make sure that there are no errors. Okay, good. You close and tick. Some of these things you need to experiment by yourself, you know. So if you think Porter is reselecting bus for you is good for you, tick, right? Like that you get to learn. So here I'll press start, and then it will start transfer columns. So it says the members listed above are either fully unsupported or supported by beams or slabs. This is according to the placement level. So maybe the flashing or what is not okay, but you can still say okay. So it says problems encountered. Do you still want to? You can still continue. It will give you the report nonetheless. Still remember design. Oh my god, runtime. It will go off. Uh oh. Let's rerun it. Sometimes it gives, but I haven't encountered that runtime error in a while. Close. Yeah, this is what we're doing. Okay. Hope that doesn't become a persistent problem. Go to analysis, building analysis. Okay, it's maintained. Let's see, material 460. The bar sizes. Oh, it didn't change the bar sizes. Okay. Oh, it didn't maintain the bar sizes. For my columns, I said I only needed what 16s and 12s. Okay. No, I won't do concrete walls, but concrete beams, I need 12, 16. I won't even check 10 this time, just 12 and 16 also. I do not need this. Oh, okay. My slabs, just 10s and 12s. We'll do 10, 12. Okay. Ribs, I do not have any ribbed slabs, but I do have a lot of links. So I'll say I only need 8 for my links. And then, look, the Berlin didn't change. Okay. I need S3 apply to all members. Change and changes. For my foundation, I need 8. Why 8 links also? And I just need maybe 12 and 16. 12, 16. Okay. And then I'll go to analysis. You see, it ticked the video analysis. I'll just do that, press that. Okay. Why is this runtime thing? Must be non-negative unless and the size of the collection. What is this? What? November. Okay. I do not know why we're having that runtime here. Could it be because of the columns? Anyway, let's see. Let's identify one of those columns. Um, so, all of them on the fourth floor. On the fourth story here, have they're given a problem, right? Fully unsupported or supported by beams, and it's good. Which ones are on the fourth? On the wall plate. Oh, okay. Hmm. Okay, let's try to check them and see what the problem is. Okay. We go to the fourth floor, and we've got these. So it's saying we can change the support type. Let's see. I'll click on it. Properties. Here at the bottom, it gives you the kind of support, so column and condition. So these are hinged, one hinge on the top, one hinge on the bottom, or fixed like that. I'll maintain that. In fact, let me just select all of them. I'll go to the I'll change to a plan view, still on the wall plate, filter, and say I only need my columns. Select. Did it select? It did not. Need a funny sound. Let's see. Let me go to my 3D view. Okay. Ah, it appears as if we added these in the middle. I don't know where these came from. Oh, I was placing. Let me undo. I wasn't selecting, I was placing. That would have been a very big problem. Okay. So I'll go to plan view because I was on the column command, so I placed. So I'll filter and then I'll select again. is not responding. So the very bad details behind. Anyway, let me select, deselect, and select the column. Otherwise, I have to do it one at a time. First, select properties. This end is supported. -7. That's okay. We'll go to and the other one, properties. Let's see what happens if you go to the design. Here, still member design. You select, says the analysis are not up to date. Oh, it actually did perform an analysis. Let's see. So go to 3D and then there's a button here that gives that diagram. I hope you guys are following. Here, when you close this, here there are a lot of these small icons, but this one is what you're looking for. It's called the visual interrogation. When you click on it, it's got a finite element contours, lap and what. You can carry out an animation. But what I'm looking for specifically is this design status tab. So when I click on it like that, it shows me that my columns have been designed and they are currently under an expired analysis. However, for the steel, it says not designed at all. You see, they are white. Let's try to run the analysis again. Or visual interrogation and animation. Don't we have like a stick? Look at those things that we're recording. Remember, where you draw a simplified thing over. Okay, I'll go to my visual interrogation, design status, go to analysis, building analysis. Is anyone also following? Is anyone trying to run an analysis right now?
Trying, but it's refusing.
What is it saying?
For me, on the pre-analysis, it was saying that the axis have got an error somewhere, something like that.
Oh, so they probably weren't perpendicular in your case. So we'll do analysis here. It's saying it hasn't performed the building analysis, it's crossed. So we have to perform so that it can be ticked here. It gives us 0 errors. We close, we select, and then start. If it gives me, I do not. If it gives me that problem again. Okay, this time it didn't give me. Maybe because I didn't select a steel member. Okay. And you can see it's given me this green. And all of them have actually passed. Green means okay. Let me try. And how do you stop this animation? Stop. Okay. Oh, so the design. The problem is with these. Do they have a top? So the concrete went through, but they still did not. No, they do not even have it. Oh, could be maybe because of the way that I had selected. Okay, the lateral loading. Okay, Let me try. If it gives me that problem, I'll go with the default settings and then yeah, it could have been maybe because of the bracing. Hmm. Okay. Analysis. We've already done the building check. It's ticked. I'll select all of them. I'll start. If it gives me that problem, I know where the problem is now. Okay. Yeah. Okay. I think I may have an idea of where the problem is. Hmm. Okay. Analysis. I'll run through. The parameters are okay, but the loading combination is not. I think the G plus NQ. Okay, no soil pressure, vertical combinations. 6 2 is okay. Load cases. How about delete everything? It was small letter N, wasn't it? I think it was these. Where is it? Remember? Okay, shift. Mm, yeah, I remember I selected something like shift. Different combinations. What was that? Okay, let me try to select everything. Horizontal, that is selected also. Delete this, everything, and then pre-analysis. Oh yeah, it was this one. Okay, okay. Yeah, and then that and that. See? And then let's try to run the analysis again. Didn't take no errors. Select everything. Go to assessment page. Hmm. I don't know what the issue is. But anyway, guys, might be a problem with this model. So let me try to. I've got a backup mode. Fortunate. So I hope you're still following. I'll use this other one, same one, but it's just in a different. For it, it's already been analyzed. When you go to 3D, you can see that it actually does have the foundation bases here, the pads. So suppose that error message was not popular. Maybe it could be a problem with my software. But what I'll do is, let me just create, before I can do this, let me create a backup. I'll go to my documents because in the remnants. I'll go to Prota 2018 and then here in the, where was it here? I've got this one. So what I'll do is I'll just zip it so that I can, if there's a problem, I can always go back to my original file. So show more, and then I'll compress it, and then I can go back to my code. It's like I've frozen it for future use. Okay, so here you can see that this structure is the same, right? 3D, everything is the same. We added purlins, the trusses, and so on and so forth. So what I can do is, suppose we didn't have these bases, I'll go to the ground plan, and then I'll delete these foundations like this. I'll filter, and then I'll deselect everything, and I'll say footing, and then I'll select them all like that, and I'll delete them. Okay, so that we can have a similar structure, that one. And then I'll go to my analysis, building analysis. Oh, it's actually 9:30. Building analysis there, and then you see that most of the presets selections that I've done in the previous one are the same ones that I did here. So the parameters remain the same, except this one I didn't add any title. All of them are braced. Loading is just the dead, that one. Foundation I use is 150. The codes remain the same. Okay. And then loading combinations, just these combinations for the vertical and the horizontal. Dead loads are being defined as G, live loads are being defined as Q. And then 1.4, 1.6, this one is only no in the like X, the horizontal, also operational temperature. Okay. And then okay, what else? So in the background there you can see, because I made changes, it's saying it's turned yellowish gold here. So it says it's an expired analysis. And then here the material you can see is C30 460, except I didn't change. For here I was using T's. For example, if I go here, I click on ribbon. Where is that where you needed to change the letter? The materials. Okay. Here you can change it as Y. And then also here you can change. Okay. You select your grade, it's Y. It's changed. And then for the columns, here I only use 16, but I can say 12 also. And then no shear walls, no load bearing walls. Concrete beams, I would like to have, okay, I'll say 12 and 16. Slabs, I'll say 10 and 12, okay. Links, I'll only use 8. Now say okay. Here it chooses the steel gate of S355. Okay, and then I'll go to the analysis now. Everything is good. Beauty model checker, see if it gives me any errors. None. And then I'll tick these because I want it to design everything, and I'll run and start. If this one fails, then it's just a problem with my software somewhere. Mm. This one went through. You see, so okay it. I hope that when it says building analysis completed and it was successful, so you okay. and then you close, and then you'll be able to see which ones have failed in red and which ones. Unfortunately, in this video, the problems have. And then it's only these beams that have failed, the steel beams. So if you need to change, it means you need to change. So yeah, you need to change the section. So what it means is that here we're using, what is this one? It's a 553, 553 210 109. But for this one, it's also a 553, but I don't know. Maybe because of the span. So what you can do, you select it, then you right click, and then you go to steel member design. It will give you information of where the problem is. So here it's this thing of ratio. The bending check in the y direction. The z is okay. So somewhere here, not here, there's a problem. So what you can do, you can either show design process like that, and then if you're really good at if you're really good at finding troubleshooting like that or finding problems in structure mechanics, then you'll be able to see it quickly. Also here you can press on the check design, or you can change the section, because really if there's a problem with the bending check, it's a deflection problem, it means you'd have to increase the member size. So you say change, or you can check the parameters there. You change, and then you want to maintain the BS code. You click the UBs. How about if you use something like a 312 by maybe 272? How will that work? You're okay. It passes. You see? That error that we had before. But then that's a trade-off on an economic point of view also. How about, let's see if we can have something within the 210, maybe 138. Let's see. Ah, the problem is there. Okay, if that's the case, then we'll get the one that the 272, and then there everything is good. You select, the problem goes away. This is probably asking for the same. So we go in, we select like that, we perform a steel member design. I've got a problem with the bending check there. We change section, then you probably need to increase it. Let's try with 138, because that one goes, the span is short. That one, the span was very long, so you okay it. And then yeah, so meaning this, the secondary beams probably need to increase them. You perform a steel member design, same problem. So you go in your UB, we're using a 254. How about we use the 305, and maybe let's say 48. Let's see, does that change? No, it does not. So how about a bigger one? Will that change? It does. You okay? The problem goes away. So at this particular point, I know which member will accept and which will not. Might as well just quickly change them. 305, when you press on it like that, you go there. I know exactly what the problem is. It's requesting for this big one. Eh, it refused that big one. So you need to change. Hmm? Are we still? Okay. Oh, there's a message. Oh, the stairs here, Paul. We'll use the steel. We'll just anchor it to the ground floor. Okay. So here, let's see. It refused that one. Let's try this one. Maybe the 57. Ah, it accepts. But then, anyway, you're better off having the same. If it's a bigger one, better you have it uniformly. instead of going to buy a big one, a small one doesn't make sense. So since this one is accepted at 356, let me see. Yeah, means we have to change this one. So it was the 356, wasn't it? It was the 51, right? Select, and then if you do not want to do this in 3D, you can also do it in 2D. Just remember where the problem is. It's on the first floor. So when I go to the plan view, I need to go to, all of these are green, meaning it's okay. I need to go to my first floor, and then I can see where the problem is. You see? So I have to click it, perform a still member design check, and then change the 356, right? 51, and then it refuses. Yeah. How about the 67? The 67 says okay. So you have to do that until it gives you all greens. So that's for steel. But for concrete, what you do is you go to either a 3D or a 2D, and then on the ground floor you select, and then you go to the column section design. Alternatively, you can also check here in the column steel details. It will show you, like, this is the 00, level 00, the ground floor. And then from there, it's got a step of 200 where you can place your base plate, and then you can put your steel beam, right? And then here it shows you that we are using, it's a 400 by 400. The stirrups are cut at that length. The length is at 1/6, and then they are of size Y8 and they are 10. If you like, you can do a manual count. Here it says 10 Y8 spaced at 150. 1, 2, 3, 4, 5, 6, 7. Eh? 1, 2, 3, 4, 5, 6, 7, 8, 9. Should be a 10 somewhere. And then the bigger bars there, it tells you they are 8Y16. 8Y16. But if you needed to change, this is where you change. You select, you perform a column section design. Click. Someone requesting to join. It's finished. Uh, and share link, get a link. Connected. Oh, okay, guys. Let me share the screen. The previous session expired, so I hope you can see. But it's exactly where we ended it. So I was saying, I've shown you how to change sections for steel. It could either be a UB, a universal beam, or UC, a universal column, or purlins, or channels, or angles. But for concrete, you select the concrete element, be it a beam or a column. In our case, a column. You right click, you go to the option that says column section design, and then it shows you all that good stuff. For example, here it says the dimensions. It's a 400 by 400. The network is not good. Is the network working for you? Do I need to buy a bundle? So it's finished. Okay. Right. Okay. I think we should be going back online again. Uh, okay, my network had a problem. Oh, you're still there. Okay, let me just show you how to load in Prota Structure, and then we can call it a day. So
Oh, okay.
I hope you can see my screen. Okay, still sharing. So what happens is that, like I was explaining, you click on your element, concrete element. You right click, you go to column section, and then it will say,
So I can't see screen.
oh, maybe it's just lagging. Okay, let me stop sharing and share again. You cannot see the screen. Let me do this. I'll stop and then I'll start. And I'll share the entire screen. Mm, I don't know if you can see it now.
Yes, I can see it now.
Okay, so select the column, right click, column section. It gives you the dimensions. If there's any eccentricity, it tells you L1 over L2. It also tells you the cover. So here, let's see if you can change the cover. So say 30. Watch the picture. When you update, you see, it reduced. Maybe to make it more significant, 100. Let's see if you update. It's too much. You cannot. So maybe 50. Yeah, 50 is accepted. But for me, I'll keep it at 30, like that. And then it shows you C30 grade, and then it also shows you the way that the way in which the steel will sit. You have three here, and two in the middle. And then when you go to the right side, it tells you here you can change the area of steel required. It tells you 20 millimeters. So here, if you like, you can change according to the way that we selected. You can have my white 12. Let's see if it will accept these white 12s. And then you say okay. Let's see if it's still, yeah, still passes. But let's give 16. I'll change back to 16 to 16 and 16. Also, if you'd like to change the way your links sit, just go there. If you'd like to add an extra clip, you go to links, link patterns, and then you've got all these options: single, double, triple, cross. This is for columns, this is for walls. So suppose I needed double links. I'll select, deselect, selected everything. I want double. I'll say yes. And then here in the quantity, and the corner you can change. Maybe you can say you need two. You see, it will add more columns. But for the link, where is it there where you add an extra link? Oh, here, edge. So suppose you needed two, you can add here. There, you see, you can say two. Or you can add another there. And then you can select whether you want a triple. Anyway, you can play around with that. And then the slenderness also here it tells you. And the shear design, the spans. Another thing that you can do, you can perform an interactive where like it will do for you. Personally, I do not like it. And also you can view your bar bending schedules here in column analysis. Yeah, so you can confirm like that and you'll be able to see your schedules. This is the moment, this is the shear, but it can also draw. I remember having seen, where is it? So for example, if I okay it, I can go to, should have column analysis results, load combinations, list, but also you can perform a report. So these are the results for the analysis. If you would like a report, just press on the column individually, and then you can also you can update those end conditions. But where is that report? I remember. Okay, let me do it. Let me put it at the top so that the options can come like that. Check. Anyway, member tables. Another way in which you can check for a report, you remember the axis? We had that thing also here. What is it? Is it here? Parameters. Anyway, when you go to the analysis, video analysis, you can do a post. Remember that button? The post analysis, you can have all the reports. If you are doing a project that required you to, I think even here, if you are doing a report and that required you to perform your, you can do analysis results display. It will create like a stick figure thing here. Remember how we would draw, what was that thing that we would do while we draw sticks in order for analysis? A free body diagram. Oh, it's because someone interrupted. I received a call. So there, you see, and then you can have frame, you can have nodal results, display, these nodes at the bottom there, and the diaphragms, and then also the contours, all of that good stuff. The elements, if you don't like the loading, what, that's for this. Also, you can do that, and then you can import everything. For example, when you select this, you push it that side. You select that, you push it that side. It will give you the same.
Mr. Shura, I can't see the screen again.
Oh, okay. Let me just stop and share again. Hopefully you can see it now. So this is the report thing. You see, for the first story, when you click the second story, When you click it, you push it, it starts. And then when you next it, you can create the report next, and so on and so forth. Then you generate this report. But there's also the other way in which you can have a PDF, as a matter of fact. Which one is it? Okay. Now the other thing, beam sections, story beams. Yeah, when you do this, yeah, that gives you that. And then you can either select a PDF export, and then it will give you the beam utilization. But also this design report here, you can either print loads, print what. When you click on it, it will give you all the information like that. It's just like this one is for steel. Let me choose for columns. Uh, Here, column section design, you click, and then you can either check the column tables. It will give you something like this: column rebar list. 1C1 gives you the dimensions, longitudinal steel, the lateral steel, and so on and so forth. And then you can print, then you can put it on your PDF, for example. How about if I want to, anyway, let me not make the video any longer. I'll click like that. Okay, let me just put it on the desktop. Like that. We go to the 25. Where is it here? There. And then you can say you create a folder that says reports, and then you select it, you save, and then you'll be able to check the reports here. And then you can share it with someone. So you can either print it, you can share it, or you can attach it to your analysis or your drawings, like that. The other thing that you can do, let me show you. Now with Prota, you can put everything on a sheet, and then maybe this is also something that I'll review in tomorrow's week. When you go to a concrete design, here there's a thing called Prota details. So when you select it, it saves, and then it gives you an output. In tomorrow's video, maybe we can do a skill check. See how it saves. Okay, so Prota details should be loading very soon. There. See, this icon is for Prota structure. This icon is for Prota details. So this is where you create your detailed drawing. You can either auto generate, or you can create a new one like that. And then when you go to form plans here, it should be a drop down here. Let me show you, because the screen is not so good. A drop down there, it shows you. So when you click this, you right click. When you say draw form plans, here you've got all these options that you have. You can either put to a title, insert to a title sheet on a scale of 1 to 50. You can also select a type of paper. For example, if you want to put it on an A1, what do you want it to print? The rebar? Do you want it to draw the column dimensions, strip footing dimensions, and so on and so forth? So when you press here on draw and then you select like that, it generates and it gives you bar bending schedules like that. So our paper size was small, so you can delete this, try to put it on an A1 form plan, maintain, or A0, maintain A0, draw, you select like that, it puts them in the title block and it gives that information. So for example, just that it looks so good, the title block. Let me try to print it without inserting it on a sheet. So when I press like that, you'll see this is far much more neat, and then it will give you the reinforcement shape, yeah, and the shape codes and shapes themselves, and the bar marks. So for example, if you go there, it tells you this is a 6 bar mark spacer 250 T1. So bar mark number 6, you go and check. Okay, let me check this one. That's curved. It is bar mark number 6. I'll find it here, bar mark number 6. I expect it to be curved there with the 300, because also here it said that it curved 300 and the length is 1150. So bar mark number 6, 300 there. So this plus this, 850 plus 300 gives 1150. So that's for the form plans. For the column also, you can draw these column elevations like the ones that we had seen. So when you click like that, it gives you this information like cross section, showing you the rebar, the reinforcement, and then you can see that this is steel. So what you can do, once you finish column elevation, you can draw the column elevations like that. You select and then the this column elevation, it shows you. Oh, did we show how to add foundations? We did not. So here when we go to, can only draw column schedules like that. These column schedules. So now how you draw the bases, you go to the 0, 0. I'm surprised Paul didn't mention that we had forgotten to draw the bases. So when you go to 3D, you can see that we do not have bases. So what you do is you go to 0, 0 here, floor plan, and then I guess this is where I end the video. When you select the column, you right click it. It says you can either insert a pad base or you can insert a pile cap. Since this is not a multi-story where we need pile caps, I'll just insert a pad base foundation design. So these are the base properties. It gives you the label F1, it gives you the depth. You can either have it in 300, 200, the thickness, 400. The surcharge is that thing, the neck, like the eccentricity is 0. It shows you the allowable stress of so the one that we had selected, and then it shows you the steel bars. So here you need to calculate before it can. Okay. So you go and calculate here. It shows you all this information, the data, footing dimensions. You can either have like a square where all of them are equal, or you can have maybe this is 2000 like that, and this is whatever. For me, I'd much rather have them be and then like 1.5, and then the eccentricity is 0. Here it gives you the soil stress. All these calculations okay, and then it gives you a punching check, x direction. It also shows you the spacing. This, previously if you're in school you probably need to do these and calculations, and then when you okay it creates the base like that. You do the same there. You insert a part base. You calculate. You select. You want a square. 1.5 will not allow. You see, cannot go lower than 1.5 because the loading on that particular point it requires that it's greater than, yeah. So you select. Alternatively, if you think this is too much, you can just select them all like this. You filter like that, and then you select the footing or the columns like that. You highlight, they are all selected. Then you can create either a combined where it will be one thing. Let me show you what I mean. You see, it will be like a raft, like that. When you go to 3D, you see it's like a raft foundation there. But that's not what I wish. I'll delete. Okay, let me go back to my plan view. I'll select it and I'll delete it. And then because I had I can remove the foundation grouping and group them. So now I've removed the foundation grouping and now it's just one. Alternatively, I can just create like a similar one where if I select like that, right click, I can insert a similar. It will tell me create typical footing, meaning they'll have the same size, like a typical detail. And then 2.5, select, create. You see all of them are 2.5. Yeah. So you do that for all your footings. I think we can end the video here. You do that for all the footings. You guys try to insert on the other one, on the others, and then if you can share your pictures of your analysis once you analyze. Share them in the group so that I can show you how to load this structure now. It wasn't loaded with block work. Like in the next video, we can load it and perform the analysis again. Yeah. So if you've got any questions, guys, you can let me know.
No questions for me.
No questions here.
No questions. Okay. In that particular case, then by the end of this week, we should have finished this structure, and then we can do a different one, or we can have a different instructor come in. So thank you so much, guys.
Thank
I
you,
already
Mr. Shu.